Hello, everybody, wherever you are in the world, and welcome to this session of our Forge DevDan. And in our Forge DevDan series, we share a presentation about Forge around each month, and Forge is the Atlassian developer platform. I'm Caterina, and I'm a developer advocate here at Atlassian, and I will be your moderator for today. Just a quick recap. In our previous events, we covered various technical aspects of Forge, like Forge SQL, the latest news about the Forge UI, and how to integrate external services in a Forge app. If you are interested in these topics and couldn't join our live sessions, you can find the recording on the Atlassian Developers YouTube channel, and I'll post the link in the chat right now. Just give me a few seconds. Here it is. And this session today is going to be pretty exciting and also a bit different from the usual presentation. That's my personal opinion, and I hope you will agree at the end. Today we have 5 groups from the University of New South Wales here in Sydney, and they will be sharing their experience building their very first Forge app. First of all, I want to say that I'm very amazed about what these students have been able to accomplish in just a few weeks, starting with no prior knowledge of Forge. So good job, everybody. And I hope our audience will agree with us and also send their compliments to you. All the projects that we will see today are AI-based, and they all use different large language models. Just to give you an idea of what we will be seeing today, we have a content summarizer app, which also performs text-to-speech conversion. And we have a few apps that show flashcards and quiz generators from the Confluence content. These apps have all been built as part of the Capstone project of our students today, and all the design, architecture, and coding has been done by the students with no direct contribution by any of us. So again, good job. A few of us here from Atlassian acted as the customers and provided requirements and feedback during the app implementation, but again, no coding from us. Before we start with the presentation, which is, I think, why we are all here, I want to share a few reminders about our live webinars. So the first one is, unless you are asking a question or maybe answering it, we ask you to keep your microphone on mute. There will be a live Q&A opportunity at the end of the session, but please feel free to use the chat to interact with the students and ask your questions as we go. Our goal for this session is to finish at 5:15 p.m. Sydney time, which is around 75 minutes from now. That should be more than enough for all the presenters and to complete their presentations, but we might reach the end of the session if there are a lot of questions. And if that happens, we ask you to post your question in our developer community, which I'm going to share here in the chat. There as well. One last thing, as a reminder, this session is being recorded and will be shared on our Atlassian Developer YouTube channel around a week from now. And this helps so that if you want to rewatch some of the sections that have been presented, you can do that easily. And it also helps other developers who weren't able to join our session today to watch the content, as we know that we have a very global audience. So I know we are recording because we did that at the start of the session. And so that's it with my introduction. So let's kick it off with the awesome presentation from our first group and all the other groups.
Hi, everyone. We are the first group of the name we will graduate. So I will share my screen, and then Ibo will be the first presenter, and then will be the live demo of our app. So I'll first share the screen. Can you guys see it?
Yes.
Okay. Yeah, Ibo, you can start your presentation.
Okay. Hello, everyone. We are group We Will Graduate. Today, we are going to present our audio summarizer app. This tool is designed to save Confluence users time by generating both text and audio summaries, providing quick insight without the need to read through long blocks. Let's dive into how each component works to bring this functionality to life. The app combines text summarization and text-to-speech functionalities, allowing users to convert lengthy blocks into concise summaries and then listen to them on the go. With a user-friendly interface, the app provides robust customization options. Users can tailor summaries to their needs by specifying additional requests, setting the summary length, and selecting a preferred language, making the experience highly flexible and relevant to individual preference. To enhance engagement, the app includes a question suggestion feature based on the initial summary. By analyzing the content, it generates diverse questions that encourage deeper understanding and interaction. Users can select a question that interests them. This prompts the app to create a secondary summary, which aligns more closely with their needs. Beyond the summarization, the app enriches the user experience by incorporating text-to-speech technology. This TTS model converts text summaries into audio and offers various voice options, such as gender and emotion selection, while supporting multiple audio formats and the playback qualities. Audio playback features include play, pause, volume adjustment, mute toggle, and repeat. For longer text, the app divides the content into manageable chunks to ensure smooth processing and real-time feedback without delays. By combining text and audio summaries, the app caters to diverse user preferences, enabling users to access information efficiently anytime, anywhere. Next, we will move on to our live demo part.
Okay, so I will go through the lab demo. Firstly, the audio summarizer backend is built with two core functionalities, text summarization and text-to-speech conversion. Let's start by discussing how blog content is retrieved from Confluence. So content retrieval is implemented through the getContent function, which uses Confluence REST API to fetch raw content. The request expands the body.storage field here to extract the formatted HTML content. So on the left-hand side of the page, you can see the Confluence platform. And when you click on a specific blog and our audio summarizer app, you can see the audio summarization section. And looking at the code, once the content is successfully retrieved, the text summarization process begins with the setup of the OpenAI client. The getOpenAI client function validates the presence of the OpenAI API key, which is securely stored as a Forge environment variable. After validation, the client is initialized and configured to interact with the GPT model. And then the text summarization itself is handled by the generate summary function. This function generates prompts based on user inputs, including the customized summary length and language preferences. Users can also include additional requests, such as specifying a particular tone or emphasis for the summary. The function constructs a prompt tailored to the input and sends a request to the OpenAI's endpoint, specifying the GPT-4o mini model. The API response is passed to extract a generated text summary. So looking at the summarization UI, you can see there's three parts. You can specify the additional requests, the three different summary lengths and different languages. If we click on Generate Summary button, it will also show a loading bar. And after the summary is loaded, you can see a medium length summary in the language of English. And at the bottom, there is also some recommended questions based on the generated summary. And for example, if we click on the first one, the key steps involving in the integrating the Google TTS API, it will load and show the answers based on the questions. And this is the secondary summaries based on the question and the original summary. And you can also specify some additional requests. For example, tell me about the deployment process and maybe choose a length of short. And then it will convert to a short summary talking about the steps to deploy the TTS API. And then I will move on to the audio conversion part by clicking on the Convert to Audio button. And let's look at the code again. So first, we need to set up the Google text-to-speech client. The get Google TTS client function is responsible for initializing this client. It starts by retrieving the required credentials from environment variables, such as Google client email and Google private key. The function then initializes the Google Cloud text-to-speech client and sets the proper project ID. The function ensures that the TTS client can be reused across multiple audio generation requests, improving both security and efficiency. And then once the TTS client is set up, the audio generation process is handled by the generate audio function here. The function accepts users' defined parameters, including the language, voice, gender, emotion, and speaking rate. These parameters allow for extensive customization of the audio output to match a user's preferences. The function dynamically configures the TTS request by constructing a TTS request object with the input text, a voice object for the voice settings, and an audio config object for defining audio properties such as encoding, pitch, and sample rate. The sample rate and voice configurations are tailored using the predefined mapping for the emotion and audio quality. The function then calls the Google TTS API's synthesize speech method to generate the audio. The API's response is validated to ensure that the audio content is successfully generated. If no audio content is returned, the function logs the error and raises an exception. Upon successful generation, the audio content is encoded for easy streaming or downloading. So let's look at the UI again. So we have male and female voices, and then different voice emotions, and different audio formats for the downloading type. And then we have 3 audio qualities, different playback speed, and also the volume, and which can be adjusted by the drop-down menu as well as this control bar. And when we hit the Generate Audio button, it will show the loading bar again, and you can either play or download the audio for future
To deploy Google
listening.
Cloud's text-to-speech,
As you can
TTS,
see, as you can
API
listen,
in your end-user engagement by converting
here is
text to
the
natural-sounding speech.
audio of the
To deploy
generated
Google Cloud
summary, and you can mute it, unmute it,
TTS,
and then download it and to listen
to deploy Google Cloud's text-to-speech,
in
TTS,
different apps. And then if we want to listen to the audio in a different language, we need to first generate a summary in that language, for example, Spanish. And then it will generate a Spanish version of the summary, as well as the questions in Spanish, but also the answers. And the questions are in Spanish. And then if we click on Convert to Audio and choose a faster speed and hit the generate audio again, you can listen
Google
to
Cloud ofrece una API de texto
the Spanish version of the
a voz, TTS,
content.
a experiencia del usuario.
This is the overall of our audio summarizer app. And if you have any questions, you can ask.
Cool. Yeah, thank you very much for presenting.
Thank you.
So yeah, we will have some time at the end for Q&A, but please
Okay,
post
yeah.
them in the chat if you have any. Like maybe other groups can also share their questions, because I know this is the first time that you are seeing each other's project. So feel free to ask each other questions there as well. And yeah, it's now time for group number 2. I think, Zachary, you're starting.
Yes, I'll just let Christina share her screen. So before we begin, congrats to the previous team that just presented. Your app looks amazing. And I guess we'll just get straight into this. So hi everyone, thanks for joining us today. I'm Zachary Moses here with Maddie, Christina, Neera, and Mohan presenting our Capstone project. And today I'm excited to introduce Cardify.ai, a custom UI flashcard app which leverages AI to make flashcard creation quick and easy. So today's agenda covers an introduction to Cardify.ai, how we use Forge modules to build it, and some limitations we encountered. And due to time constraints, we'll quickly skip over some detailed slides, but they'll be available in the recording for anyone who wants to review them later. So recognizing that Confluence lacked a dedicated flashcard app and that manual flashcard creation was time-consuming, we created Cardify.ai. Developed using Forge, Cardify.ai is a fully functional app that allows users to easily create, organize, and review flashcards, either manually or with AI. It enhances learning, collaboration, and progress tracking, and it's all within Confluence. So we'll be looking at a screenshot of Cardify.ai's homepage, and this is where users can create, edit, organize, and study their flashcards and decks. And in terms of Forge modules, Cardify.ai utilizes 4 different modules. So the global page module is the homepage for managing flashcards, decks, and study modes. The content menu module lets you create flashcards while editing Confluence pages. The context menu module uses AI to generate flashcards from highlighted text. And the byline menu module scans an entire page using AI and creates a full flashcard deck. So moving on to our live application demo, we're going to start with our app's most basic module. So this is the content action module in Forge, and this allows users to quickly create flashcards from any Confluence page. So to use it, you've got to click on the top right-hand side menu buttons and click Create a Flashcard using Cardify.ai. And here a mode will open where a user can enter the front and back of the flashcard, add an optional hint, and actually lock the card as well. So once they click Save Create Flashcard, the flashcard will automatically appear on the Cardify homepage. And we'll be exploring how the other modules work now. I will pass the microphone to Neera to present the AI features of our app.
Thank you, Zach. Hi, my name is Neera, and I'll be going through AI flashcard generation for Cardify.ai. Next slide, please. These features can be accessed using the whole page, so content byline, or using selected text with context menu. And there's also an option within content byline to generate the deck title for all the flashcards saved within the Confluence page, which will be live demoed right now. So just to the demo. So context menu allows the users to choose a text anywhere on Confluence page, and then uses functionality where you can click and generate AI flashcards. So it just shows up with this. Once the flashcards are generated, it will show up like this with the front and back. The users can edit that, also add a hint as optional, and lock their card to make it private before they save it to the global page, as shown. Content byline is a little bit different to this, as you use the entire page to generate flashcards, so you can access it there. And it shows 2 options where you can generate the deck title. So it suggests a title for the Confluence page if you don't want this one. And there is also a flashcard generator to provide flashcards for the entire page. So as you see, the deck title has already been generated. So once the flashcards are generated, as shown, the user can then optionally edit the deck title and then save the deck once they're done. So then, once the deck is saved, they can go to the global page and then once the global page loads up, notice how the deck and the cards are saved under the auto-generated tag, just for the users to be able to toggle over. The user can also click on View Source Page, which takes you back to the Confluence page that the flashcards and the tag were generated from. So going back to the slides now. So as shown in the slides, we used 3 models. So question generation, question answering, and title generation, all from Hugging Face. These models were found through extensive research and analysis. Next slide, please. For example, this is a sample analysis that I did to pick the Q&A model. Using F1 scores and EM scores, we found that Spanberg performed the best, so we ended up using that for our question answer generation model. Next slide, please. These NLP models integrated from Hugging Face can then be used in Python. However, there's no straightforward way for Forge to access such files. So for development purposes, I chose ngrok to host this code. This server creates a public URL for the code remotely hosted via a fast API, then allows anyone to access our generation. Next slide, please. In summary, there's a diagram that shows how the front end fetches the information, sends it to backend, and then the module receives the generated information. And then once the user saves the deck and the flashcards, they can then access it via the homepage. With that, I'll hand it over to Christina to explain how our homepage works.
Thank you, Nira. Hi, everyone. My name's Christina, and I will be taking you through our global page module. The global page module acts as Cardify.ai's homepage, where users can view, organize, and interact with content created site-wide. So we've made all key interactions possible within the homepage, enabling users to create, edit, and delete tags, decks, and flashcards with ease. These come in the form of modal pop-ups, which are available to the user through a single mouse click. Now, we understand that as more users create content, the homepage can become increasingly cluttered. This is why we have added filtering and search systems in the form of toggles, search bars, and tags. So on the top right, we have a personal versus all toggle and a search bar. The personal versus all toggle is unique to our Confluence Forge app. As the homepage displays all created content on the Confluence site, this toggle is a way for users to filter the homepage so that only their personal content can be seen. Next, we have our search bar, which dynamically refreshes the front end on each keystroke. This makes searching for information much faster. The addition of a search bar can also be seen in our modal pop-ups for creating tags and decks. It can be cumbersome to scroll through a long list of decks and flashcards when creating or editing these components, hence why we've incorporated it here. Lastly, our tags. So tags are ways users can functionally and visually group decks and flashcards. As seen here, the user can select and or deselect multiple tags at a time, which will automatically filter the homepage based on the tag selected. We additionally have a toggle all tags, which can select and or deselect all tags. This was made possible by creating our app with custom UI, as opposed to the UI kit that is more commonly suggested. Custom UI offers greater flexibility and customization and allowed us to seamlessly integrate NUI components and external libraries wherever we saw fit. Simple examples include the sliders and the toggle buttons we see here, which were imported from an external library, amongst many others that we can't dive into for the sake of time. Thanks to Custom UI, we could create and customize these elements to align with our client and our team's design vision. With that, I will now hand it over to Mohan to explain user interactions with decks.
Thank you, Christina. Now we're going to go through deck display. So to open a deck, you simply have to click on the deck in the global page. And when opening a deck, we're able to access study mode and quiz mode. So when we go into quiz mode, as you can see, the user will select a tick or a cross or a skip, depending on how they feel about the question, as this is a self-marking process. And the number of correct and the number of each responses is then tracked as shown in the summary page to the left. So depending on how each question is answered, we have a whole reordering system. So as you can see, the first card is 3 + 3, and that is because skipped cards are pushed to the front, because that's how the numericals comparison with cards go. And then as you can see, when we do this final card, the summary is then again the user can then again see the summary. And then when we go into quiz results, we are able to see both results from both of the quizzes that we've done. To do this, we had to use a quiz result dictionary, which tracks not only the rewarded deck, but the number of correct, incorrect, so on. And we get an array of these quiz result objects to get all the quiz results. Okay, now we're going on to study mode. So study mode is extremely similar in that they use the same reordered deck. However, differences lie in the fact that there is no timer, as you can see, and also the user is able to cycle through as many cards as they like without having to go to the global page. Okay, now I'm going to hand it over to Maddie.
Thanks, Mohan. So I'm Maddie, and I'm going to quickly run through a few limitations we've faced while working on this project over the past 6 weeks. Firstly, for the modules within the Confluence pages, the boxes that pop up can only be set to certain dimensions, which, for instance, causes the pop-up box for AI-generated flashcards to display only one at a time, requiring the user to scroll to visit the others. Not ideal for user experience, but it's beyond our control at this point. Also, we originally wanted to keep all the homepage interactions within a single module, but because of this, we were restricted to only one global page, requiring the user to navigate around the deck display through breadcrumbs. We use states to determine whether a certain page should be displayed at any given point, since we couldn't define these through HTTP routes. Another issue we have faced was the invocation limit during the AI generation. Unfortunately, AI just tends to take a while, but Forge invocations only run for 25 seconds before timing out, creating a bit of a problem. Now, to overcome this, we decided to break down big text blocks into smaller chunks of text, and then processing these individually takes less time. A new Forge EAP feature was released just about a week ago, which would allow us to extend that runtime limit up to 15 minutes, so we're going to explore this going forward. Now, for storage, we chose key value store since it was the only stable option that would allow us to make changes once declared in the manifest. However, this option does not let us query over more than 99 entries, so we had to implement a cursor solution to enable pagination. And going forward, we're going to try to move to Forge SQL, again, available through the early access program. Yeah, and that's about it from us. The Forge project has been an awesome learning experience for us as we all wrap up our bachelors. So thank you. And yeah, thank you for listening. I hope you found our app interesting. And also a special thanks to Melissa. Now the next team will present their project.
Hi everyone, good afternoon. My name is Naman and our app is the automatic quiz generator Forge app. We will start off with a little introduction followed by a demo and the code overview. We know that creating a quiz manually is time-consuming task for educators and trainers. Our goal was to create a scalable and easy-to-use app that generates high-quality, context-aware questions directly from the Confluence content, saving time and effort. Next slide, please. We were able to achieve this by integrating Confluence page content with Gemini API, which allowed our app to produce reliable questions automatically within seconds. The app hence transforms how our assessments are created for knowledge checks and training purposes, making the task easier for the educators and the users.
You can use the app in 3 different ways. The first option, individual page macro, allows users to create a quiz on any page by using the /quiz command. While the second option, single page macro, lets them make a quiz by using a URL for another page. For the third option, context action menu, users can create a quiz with one click without editing the page. Users can also pick the number of questions they want and choose between multiple choice or true-false formats.
We empower our app to use AI from Google Gemini. Mainly because we have a budget consideration and Google offers us a free tier as shown in the slides. And during our project, we had some challenges and learning from them. The first one is we switched from the UI kit to custom UI. It's mainly due to the custom UI give our developers more control to our app and offer the user more better user experience. And at first, we used OpenAI's API because it has no free plan and we have to pay based on our usage. So we switched to Google Gemini. And usually the AI will give the response to as a general test. And so we designed the prompt to let the AI generate the response in a standard JSON format so we can reuse it.
So now we'll give a demo of the application. For that, first we'll head to the Confluence page. So first on showing like how we can access the app. As we stated in the presentation, like 3 ways we can access the app. First is we have to edit the page, and which will be an in-page macro. So first we have to go search for the app and then select the app, and then we have to update it. But this will be a time consuming, and every time we need to go and edit the app. So for that, we can access the app through a content byline. So for that, we can just select the more options and just select the app, and the app will be loaded. So we also selected like a macro where we can have our app in a separate page where we can give a link where the user can just copy the link of the page they want the quiz on and just paste it over there and just take the start the quiz. But coming to the features of the application, so once the app is loaded, we have 2 options. Either we can customize our quiz or we can directly start our quiz. For customizing the quiz, the user will be presented with 2 options. The user can select the number of questions and the type of questions. For number of questions, the user will be it will be based on the length of the content. So if the content length is within 500 words, the user will be shown with only 5 questions. If the content is between 500 and 1000, the user will be given an option for 5 or 10 questions. But if the content length is more than 1000 words, the user will be presented with 5, 10 or 15 questions. The type of questions, the user can select either a true false type of questions or the multiple choice questions. So once the user selects the number of questions and the type of questions, the user can just select the start quiz button. Once the user clicks on start quiz, the content of the page is selected and sent to the Gemini API to generate the quiz, and the quiz is loaded over here. So the user has to attempt the quiz. The user can select the option which they want to select and then click on the submit. Once the user clicks on submit, if the answer is correct, it will be shown in a green color. Otherwise, it will be displayed in red color, and the correct answer will be shown in green. So then the user has to attempt all the quiz, and finally, on the last questions, when they click on finish quiz, the user will be given a score. If the so for passing the quiz, we set a criteria for 70%. If the user gets a lesser score, he will be given an option to retake the quiz. For retaking the quiz, we are not calling the Gemini again. We will be giving the user same set of questions, and they can reattempt the quiz. The user will also be given a review button so that they can review their content. So they will be given all the questions, the correct answer, and the answer they have given. So the user will be given multiple action buttons also, which will help them. First is copy to clipboard, which will allow them to copy the content of the review and use it in a later purpose. The user can also download the review. So they just click on this on the download as PDF, and they can just download the quiz review. Also, there might be a condition like the content is too less for the application. So here will be so we had a validation like if there is less than 250 words, we won't be able to generate the quiz. So if the user tries to generate a quiz out of it, it will be shown an error like minimum for 250 words will be required to generate the quiz. Also, coming back, there will be the other application also works in the same way. Once we give the link and click on start, the user can either customize the quiz or start quiz. It will first extract the content out of this page and then it will generate the quiz out of it. If the user clicks directly on the start quiz, they will be given with the default option. The default option is if the content length is less than 500 words, they will be given 5 multiple choice questions. Otherwise, they will be given 10 multiple choice questions. So here, if they click directly start quiz, so it will load the quiz. Just a second. So here, 10, as you can see, 10 multiple choice questions will be loaded. This is the default option we are having. Now we'll head to the code.
For code review, we begin with index.js, which is Forge Resolver, the backend of our application. When the start quiz button is clicked, the get text resolver function is invoked. This function uses the request Confluence API to extract the content of the page. To do this, we need content ID, which is passed from frontend. The extracted content is then formatted. After performing customization and validation, we create a prompt for Gemini API to generate quiz questions. This prompt ensures API response is always JSON parsable format and maintains consistency. Then we use Axios to make external API calls to Google Generative AI. We also use process environment variable to hide our Gemini API key. Coming to the front end of application, which is app.js, one of the main challenges was retrieving the content ID of the Confluence page, which while using custom UI. As there were no direct tutorials available like for UI Kit. After carefully reviewing Forge documentation and online resources, we found this is the best way to retrieve content ID for use case. Next, we define functions for action buttons like customize, start quiz, submit, retake, and quit. We also incorporated an external library, JS-PDF, to enable users to download the quiz questions in PDF format. For managing states and action, we rely on React states and React hook. These help us handle user actions and dynamically set the questions. The JSX code is used to create the HTML components of the applications, while if we go to the last part, then this is where we have defined our custom CSS for styling. With that, we conclude the code review of our app. Thank you. We hope you enjoyed our app and presentation. The next team will now present the project.
Thank you.
Can anyone see my screen?
Yes, we can see it.
Yeah, okay. Hello, everyone. We are Seller. We have developed an AI-powered flashcard app on the Atlassian Forge platform. It uses generative AI to quickly create flashcards from select types in articles with features like viewing, editing, and deleting flashcards. Our app offers flexible management for users. Now, I will hand it over to Patrick to showcase the demo.
All right, so hi, everyone is Pan, developer of this app. So I'll walk through the key feature of you can have everything done in 2 pages. And yeah, as a Confluence user, you can create flashcards directly
Patrick, your audio is breaking up a bit.
So for example, on this,
So maybe you can stop your video.
Is better now?
Yes. Try say something.
Yeah. I can hear me? It's better?
Yes. Yes.
Yeah, all right. Okay. So when you select the text, you see this icon. So click on this. and then hit the Create Flashcard button. So this use the Confluence context menu, so make it simple and easy to use. So now see the flashcard creation preview interface. So when you click the Create Flashcard button early, the select text was sent to Gemini API, which return 2 pairs of question and answers. So like the first one is relatively simple. So for quick memory, the second one is more complex for understanding. So user can select either both or like either or both pairs. So and assign a category to the flashcard. So let's try this. Let's click Create button. Oops. Yeah, so your flashcard has been created successfully. So to view your flashcard is really simple. So you can just create a new page. Give it a title. And in the context section, just do /flashcard. So now you see the flashcard listing page, which includes sorting options. So flashcards are sorted by creation time. So new is first by default. You can sort by oldest or by category in alphabetical or reverse alphabetical order. And also we have like a filter. You can filter flashcard by category name. So it's only gonna show all the AI flashcard or the history flashcards. And also instead of infinite scrolling, we added a pagination for better navigation. So user can use next previous button or like just the page number. So yeah, now let's look at how to interact with each flashcard. So we hover on the review button. There's a tooltip tell you what to do, like click to show the answers. So we use this stick color so to avoid confusion. The user can edit the flashcard because sometimes the flashcard are not always reliable. AI are not always reliable. So let's do this. So you see the flashcard is updated. And talk about deletion. So to prevent accidental deletions, we add a confirmation step. So when you click this asks you, are you sure you want to delete the flashcard? So if you click delete, so the flashcard is deleted from the UI and the storage. And we will also implement delete off flashcards and the reset storage in the configuration UI. So we add it. At the bottom, you can see there's like a pencil icon. So when you click this, it's gonna trigger the configuration UI. So let's do this. So you see the all flashcard has been deleted. Let me refresh this page and publish. Yep, so it's all gone. So yeah, this concludes our demo. I'd like to give a big shout out to Aromi and AJ. And Aromi is our tutor and AJ is our mentor. He's the senior developer in Malaysia. They've been very supportive and helpful from the last 9 weeks because this is the last semester for us postgraduates. We were being very busy. So thanks them very much. And Alan is going to talk about architecture.
Okay, can you hear me?
Yes.
Okay,
And we
let
can
me
see your screen
introduce.
too.
Yeah, let me introduce the architectures of our app. You can see that here is the whole architectures of our app, and so our app's architecture is designed to integrate with the Confluence. addressing the challenge of fragmented knowledge management. And the user's workflow begins with the Confluence UI, and where users can highlight text to create flashcards. This triggers with the context menu, which extracts the selected text and send it to Gemini API for the processing. And the Gemini API can generate two flashcards in the JSON format and returns them to the app for display. And the flashcards can be securely stored in the Forge storage and enabling users to sort and filter by the categories or the created time. And additionally, our app includes a micro component for the editing and deleting flashcards, providing the flexibility for the users to manage their content and effectively. Yeah, that is the whole architectures for our apps. And thank you. We hope you liked our app and the presentations. The next team will now present their project.
Thank you. It's now time for the last team to present.
Hello, can you see the screen, Sanskar's screen?
It's loading. Now we can see your slides.
All right. All right. Hi, everyone. My name is Vishesh Malik, Scrum Master of Team Black and Black, and today we're going to present our project, the AI Quiz Generator. So why do we need the AI Quiz Generator? So in today's fast-paced world, knowledge is constantly growing and making traditional quizzes time-consuming and often boring. So with the help of an AI quiz generator, we can actually create engaging quizzes quickly and efficiently, ensuring knowledge is retained and easy to access as well. Also, it is perfect for generating quiz from tools like Confluence. So what are the benefits? The benefits are quite clear. AI-powered quizzes save time, they reduce the need of printing and enhance the learning experience as well. Also, educators can focus on meaningful tasks while learners get to explore new areas of knowledge effortlessly. So let's move on to the final architecture design of our project. So in this diagram, you can see our project is mainly divided into two main components, the front end and back end. The front end is basically where the user needs login credentials to access the Confluence page, and through the Confluence page, the user can also access the quiz. The back end has several subcomponents, for example, the AI quiz generator API, which is basically the open API through which the quizzes will be generated, and it will be stored in a database. The database will basically contain questions and the options where the user needs to click from, and it's going to be displayed in the UI, where the user would also given a feedback score of how many questions he did right or wrong. Also, we're also fetching information from the Confluence page through the Confluence REST API, and it's going to be the input to the quiz generator. So now Sanskar will give you a live demo of how quiz generation process takes place. Over to you, Sanskar.
Thanks, Vishesh. I'll move on to yeah. Okay. I'll move on to the user interface part of the application. Our app has been implemented through Confluence Context Menu UI Kit, and it provides an on-the-go experience for quiz generation process by having it integrated within the page context menu. Over here in the left side of the menu, we have some nested Confluence pages already created for us, which we will be using for the quiz generation process. Now, to launch the app, what we would need to do is head on to our context menu and select our quiz generator app. And over here, we list all the Confluence pages in a tree-like structure, where the parent page would be the page where we launched the app from. And any other apps that are nested within that parent page are listed below. we have provided two ways of accessing the quiz. One is a quiz access code, and the other way is a user picker. User picker can be used to predefine what teams or members of the Confluence site can access the quiz. And the quiz access code can be used for users that weren't initially assigned, but would rather require access to the quiz later on. And then we have some quiz customization options, like the type of questions and the number of questions. You can select a combination of type of questions, like MCQ or SCQ, or all of them, or any single one of them. To select which pages need to be fed to the backend AI model, you can select the pages from the page tree. Assign the user. So in this case, I will assign the quiz to myself. And then select the question types that I'd like to generate, and generate the quiz. Now, this process usually takes a bit of time. It sends the request to the backend, and the backend then generates the questions and returns back to the user. For example, here we have 10 questions generated, all from from the content that was initially fed into the AI model. To provide the customizability to this generated quiz, we have made each UI component editable. So the quiz creator can change the question or the options or even the answers. The final stage would be to publish this quiz. This would allocate this quiz to the assigned users. And you can use the quiz access code, or if you were assigned, you can take the quiz other way. So we can go ahead and launch our quiz taker app. Now we get two options. We can either start the quiz by code or view our assigned quizzes. Now we have our latest quiz listed right here with its quiz ID. We can generate we can select multiple choice answers for multiple choice questions. We can select single option for single choice questions or true false questions, and so on and so forth. So I'll quickly finish this quiz right here. And at the end, the user will be displayed the result from the quiz. You can press back to close this app, or go to the main menu of the app. We can also start the quiz by code, and provide the code here and start the quiz again. This is for users who weren't initially assigned. That would be all for the user interface. Great shout out to Melissa for helping us through our development process, suggesting us great features from UI kits. Our learning curve has been quite lenient with Atlassian because of how well documented all of their APIs are. And we were able to get a lot of support from Atlassian community forums. Cutting to the chase, I'll move on, pass it to my teammate Satwik for continuing with the presentation. Yep.
So I'm going to speak a bit on what models that we tried out. So we went ahead and tried out the Hugging Face T5 model, and we got the question something like this, like what is the main idea of the passage? Without giving the passage, we got the questions which were kind of like irrelevant. So because of that, we went ahead with the OpenAI GPT 3.5, which is designed to generate human-like text-based on complex inputs. So these were the results that we got, which had proper sentence structure and well written options as well. So, and this is the prompt that we gave the OpenAI GPT, OpenAI Turbo. which is like given the text below, and we give the subject. Subject is nothing but the Confluence page content, and a number of questions were the number of questions that as Sanskar showed you that he had given, and question types were MCQ, SCQ, and the single choice, the true or false questions. And we also gave them the response JSON format, the format which we want the questions to be. So I'll just show you the data flow. So from the API, from the Confluence REST API, from the front end, the Sanskar had processed it, passed it, and he gave it to me in a JSON format. It looked like this, like quiz ID, quiz code, and the user picker data would be the email IDs of people who got assigned to it, and a number of questions and question types and page details. And it was fed into the OpenAI 3.5 Turbo model, which took the question types, number of questions, and page detail information, and created the questions in this format. It gave the correct answers, and MCQ, if it is MCQ, it gave us MCQ. If it was true or false, it gave us TF, and SCQ, it gave us SCQ, and the options as well. So after that, the response JSON was sent back to the front end for previewing and editing the quiz. And then it got stored in database for the quiz taking app, which needs this thing. So we have used MongoDB Atlas to store the quizzes as well. So if you want to get the quizzes by quiz access code, so these were the field to get the quiz one, and you get, yeah, you can also see the you also saw the assign to me part, which was brought from this part of user picker part of a part in the database. Also, we had hosted the backend in external server, so we had to Dockerize and put the image on in Docker Hub, and we just hosted it in a server. And as I said, we stored the data in MongoDB Atlas, and that's all with the presentation. Yeah, one thing I forgot was a future enhancement. These external server all can be cut down, and if we can use Atlassian Robo, which is Atlassian their own model. Currently, it doesn't have API, but it does have a very good chat and agent based system, which we weren't looking into. So in future, we can incorporate Atlassian Robo to make it into one Atlassian environment. And one more thing is we haven't implemented quiz feedback system, which we can do it in future, as well as create a new unique links and mailing feature, so that if a manager is going to create a quiz and give it to his employees, or her employees, so he can use this feature and send out a mail as well. And that's all from us. Thank you very much.
Thank you, everybody. So I'll give everybody maybe 30 seconds to think about a question. Otherwise, we might have some for you. And if you have a question, you can just unmute yourself and ask them directly. They can be questions for everybody or for a particular group. AJ, you should be asking this. Ian, you'll go next. AJ, do you want to unmute yourself?
Yeah. Thanks, Katrina. So I've got the question to the group, like, what was the reason that you picked MongoDB to store the quiz data for your app?
Am I audible? Hello.
Yeah.
Yeah, the only reason that we went ahead with MongoDB was that's what I was familiar with because I had been using MongoDB previously. So it was basically just that I was used to it, and that's how I went ahead with it. Also, the external server as well. Why we went ahead with that was my as my background and most of the teammates' background were in Python, so it was more easier for us to go ahead with that thing compared to as we were not that what to say familiar with the React and JavaScript things. That's frameworks.
Thanks. That's a good feedback. Thanks.
Yeah.
Yeah, that's something that I think from an Atlassian perspective surprised a few of us, like even when we saw the app the first time. But I think it's a good way to deliver this project and for you to implement this project, considering like the super short time frame, even if it's not something that we would probably recommend. We are not going to tell your mentor. But yeah, it's certainly something that like surprised a few of us when we saw this.
Thank you.
Any other question? Oh, Nick, you go.
Hi.
Nick, also introduce yourself, like say what was your role in this project while you are at it.
Yeah, I'm Nick. I want to say the reason that we're all here just because I was the matchmaker who put these projects into Comp 3900. And this is something that I'm really interested in looking at expanding further. There are other courses at UNSW that are interested in Forge as a tool. And so my question to you guys is how, if there were other students who are going to go work on Forge in the future, what would your advice to them be? What would you tell them about your experience over the last 9 months? Sorry about the voice.
There's 5 groups, so I'm not sure like how to jump in, or do you want us to go group by group?
Just jump in.
Well, our experience working with Forge was very interesting. Like as a team of undergrads, we hadn't really had much experience going through and seeing new software and really developing a project like this before. I really can't say how amazing everyone in our team was. It was a lot of work, but I think it's all really paid off and it was a really, really good experience. And like to answer your question about how would I recommend someone to go about Forge, just have fun with it. It's a developing application, it's a developing app store, but like Katarina and Melissa, who we worked with and asked questions, was absolutely fantastic. And I know that they also answer a lot of questions on the developer forums. And like, if people are using Forge and they're interested in Forge, they're likely to be testing out and trialing things, and it's quite amazing to learn and use.
I have something to add as well. I think that I think that there's a lot that is possible that's not really quite captured in the documentation, of course, because it is so new. So it really does take a bit of resilience to get through the trial and error process. And when something doesn't work, like figuring it out. Of course, there's the developer community, which is an amazing resource. And we really made use of our contact, Melissa, with specific questions. So I don't know if our app would have been possible without like that support from, the other Forge developers. But yeah, it's definitely, a big learning curve. And I think also like there's so much possible through custom UI. So I think it would almost be interesting to try and instead of like, I guess, marketing it to students as like the AI possibility side of things, but also talking about how like much can be done with the front end features as well.
Oh, awesome. That's really great feedback. Interesting to hear about like sort of there's like points when you relied heavily on your mentor. Yeah, any feedback around if we were to scale this up so you'd have sort of maybe a couple of mentors helping maybe a course of 150 students. Any considerations that you think like, oh, you probably want to do this?
As far as UNSW specific things, I think an ed forum would definitely be very useful, because I imagine there are a lot of repeated questions as far as maybe how to like connect with external services. I'm sure all of our individual teams would have gone through a similar process of trying to figure things out. So if we could refer to a common forum, that could be good. Yeah, that's
Definitely. Yeah. Do you guys use the Atlassian community? Do you ask questions on that, or did you just sort of like look at posts that were sort of other people have made?
We had mostly looked at other people's posts, but I know that some other groups have made use of the developer community as well, the Forge developer community.
The Forge developer community was really, really helpful in answering a lot of our questions. I would say that our relationship with Melissa, it was a fantastic, amazing relationship, but it was more of like, there was obviously a personal touch, but it was the same relationship as any developer would have with the developer community. So that like space for people to ask questions is really important, and we use it in our project. And it was one of the main ways that we could debug, implement features, search up solutions, and then just also credits to Maddie. She's amazing, and she figured out solutions that a lot of other people, I'm sure, wouldn't have been able to figure out. So I think that place is really, really beneficial. So that's my contribution to like really ramp that up.
Amazing. I'm sure the course team are very, very happy to hear that. Congrats to all the groups. This is an awesome work that you guys have done. And I'm really happy that you chose the project in the first place. Got to see the fruits of all your efforts. So well done.
Yeah. Ayana, do you still have a question?
No, I'm good. Thanks.
You're good. You're good. Ramesh, we saw your question. I'll just read it out loud. So, is it possible to populate custom fields with default values in create request form in JSM? We are looking to see if we know the answer, if we can find it out during the session. Otherwise, we will let you know. Mel, do you want to ask do you have any question? Maybe we'll just leave that in the chat.
Yeah, I think that was more just an addendum to what we were already discussing.
Yeah, cool. Anybody else? I'm not going to ask the favorite app from everybody. Like, I don't want to start like any competition. I think, yeah, you all did amazing.
I have a question for the teams actually, though, if we have time. If you could have had like one Forge feature that didn't exist to make your project better, what would it be? I guess maybe I'd love an answer from each team. Zach has said viewport size, and I already know exactly what he's talking about after like some pretty in-depth discussions there. Do any of the other groups have any particular features that they would have liked to see? Oh, Maddie, yeah.
I'm not another group, but I think something that we would have liked to have been able to rely on some of the EAP features. Of course, we could have, but just with the university project side of things and just it not being stable, we decided not to. But it seems like there's a lot of functionality that we could use with that SQL and kind of the invocation, extending the invocation limit as well.
Yeah, definitely. That was probably one of the cooler things that I noticed throughout the project was like just all of the EAP features that were coming online with Forge. It's like such a evolving platform. It's a shame some like more of them weren't in general availability for this project, but yeah. Do we have any of the other groups who have any feature requests that they would have liked in Forge? No? Okay.
Cool. So I'll give you one last chance for one last question before we wrap it up. Okay, sounds like that's it. So thank you, everybody. I said it many times, but you all did an amazing job. Yes, AJ, I agree with you. Great job with the demos, not just with building the apps. So thank you to all of you. Thank you for sharing your apps. And I want to say it again, just in case, somebody didn't catch it. All of this has been built from students that had no prior experience at all with Forge and in a very, very short time. So truly impressed. You all did an amazing job. And I also particularly like to see how different teams are solving the same requirement in a different way. And all of the solutions looked great. So thank you again, and hope to see you soon. Bye.
Bye, everyone. Thanks.
Thank you.